All right, this video is on 8.5 products with radicals. If you're looking at your notes, this is page 4, and then you'll have to go on to page 5 a little bit as well, so make sure you have that paper handy. All right, we'll dive right in. If we're looking at this, here's a property that we can use, and I think it's a property that you've seen before. If you have an exponent with things in here, you can rain these down, and you can have x power 1n and y power 1n like that. Well, remember, a fraction power is actually a root. So what this says is if you have multiple things in parentheses, you can actually just root them one at a time. So if you have an nth root of this and this, we can separate this. We can nth root the first thing, and we can also nth root the second thing like that. So you can root the things that are underneath the root one at a time. And that's actually what we've been doing. Well, if we use this property in reverse, this says if you have multiple things underneath, you can separate them. If we use it in reverse, if you have separate roots, you can multiply them together. So what we could do is we could take these two numbers, the 18 and the 12, and I'd multiply them, get 18 times 12 is 216, and call this the cube root of 216. And now I can go to my paper, your power card, hopefully you have it handy. And if I look at this and I want the cube root of 216, I can say, all right, cube root 216 is going to be 6, and you've got your answer. So what's nice about that is that the cube root of 18 doesn't work nicely. The cube root of 12 does not work nicely. When you multiply them, it makes 216, and that does. So sometimes it's handy to multiply them together. All right, try the next couple and see what you can do. If I multiply these together, you get the cube root of 64 like that. You get the cube root of 64 is going to be 4. These, if I multiply them, here I have a fifth root. When you multiply 8 and 6, that makes 48. And when you go a power times a power, this says there's 3 a's and multiply one more for a power 4, and you've got it. So it works when you have numbers, but it also works when you have variables as well. You can combine them and see what you get. All right, over on page 5, let's take a look. I want you to do a little warm-up problem and see if you remember how we did this. If I look at the square root of 50, what we did, maybe a month ago, is we said, all right, don't go to your calculator and hit square root 50, but what I do want you to do is to chop that into 2 pieces. And if you remember how we picked those 2 pieces, the 2 pieces were a perfect square that goes nicely into 50 and it's leftover. So the pieces that we picked were the square root of 25. I picked 25 because it's a perfect square. If you're having trouble thinking of perfect squares, just look in column 1 right here. These are all your perfect squares right down here. So 25 is a perfect square, and 25 goes nicely into 50, so it's nice. The other piece would have to be 2, and the reason is because 25 times 2 is going to be 50. To simplify it, the top one roots nicely, so I'm going to call that a 5. The bottom one does not, so I'm going to call it 5 root 2. Now, it's not perfect, but it's a little bit better because we have at least some numbers on the outside, and that's what we're trying to get. All right, think for a second. Let's take this number 1, and let's split it up. What 2 pieces would you chop that one into? Think to yourself. Hopefully, the 2 pieces that you picked were a square root 25. I got that number because it's a perfect square. It's in that column right here. And I also picked it because it goes nicely into 75. The leftover piece would be a square root 3, and if I now simplify, the square root of 25 is going to be 5, and its leftover piece is going to be 3, so 5 root 3 is going to be the final answer. All right, that's more of what we're going to be doing, but it gets a little sneaky here because now we're going to get into the cube roots as well. So here's what I want to do. We're going to take the cube root of 80. Well, here's what I want now. I want us to look at my perfect third powers, my perfect cubes, and see which one goes nicely into 80. So I'm going to look at my paper because I don't have my perfect third powers memorized by any stretch of the imagination. So if I look here, here's my power 3. Here's all the numbers that are perfect cubes right in here. Now I want to go through the list and find one that goes nicely into 80, and hopefully you're not too far on the list. You say, oh, 8. So I picked the number 8 for 2 reasons. 1, because it's in this column, it's a perfect cube, which matches this right here. And the second reason is because it goes nicely into 80. So I have the cube root of 8, and its leftover piece would have to be the cube root of 10. 8 because it's a perfect cube, 10 because it's the leftover. So if I take the cube root of 8, I'm going to get 2. So I'm going to have 2 cube root 10 for my final answer. All right, let's try another one. So let's just attack this in two different pieces. I'll have the square root of 18, and I'll have the square root of a5. Okay, so the square root of 18, let's just do exactly what we did, what we've been doing right now. So we'll go, all right, I'll call that square root 9, because that's in my perfect square column, root right there. And I'll call it square root 2. Okay, now let's take this, and this is what we did maybe the past couple days, where we've been taking these and chopping them up into perfect squares and also the leftover pieces. So there's 5 of them under here. Here's what we're going to have. I'm going to call this a power 2. I'm putting them in groups of 2, a power 2 and a, like that. This is exactly what we did, what we did a couple weeks ago. All right, so now I'm going to go through this whole thing. If anything roots nicely, I'm going to put it on the outside. And if it doesn't, I'm going to leave it on the inside. So let's try it. So if I go over here, the root of 9 works nicely. That's a 3. Square root of 2 does not work nicely, so I'm going to leave that as a square root 2. Now I go over here. There's 1 on the outside and 2 on the outside. So there's a squared on the outside and 1 left on the inside. So this is going to be my final answer. 3a squared times the square root of 2a. I got as much on the outside as I possibly can. All right, if you understand it, pause it and try the next ones. If you don't, I'll do it right now. All right, square root 98. I'm going to go square root 98 and square root a12, like that. I'm going to go on my paper, and if I look at that 98, I'm kind of familiar with these. I can say, oh, 49 goes nicely into 98. So I'm going to go square root 49 and square root 2, like that. I don't know why I got that on there. And now let's take these. Well, you could write them all out as a power 2, a power 2, a power 2. But I think we hopefully are catching on that there's going to be 6 groups of 2 in here. So I'll say the square root of 49 is 7. There's a square root 2 that doesn't work out. And then now if I'm simplifying this one, I'm going to say, all right, there's going to be 6 of them on the outside. Like that, you get 7, 8, and 6, square root 2 for an answer. Try a couple more. Here are the tough ones. Here's cube roots. We're doing a cube root of 128. So I'm going to go down my list and see which one of these, of the cube roots, divides nicely into 128. Ooh, I get right here. 164 goes nicely. I'm sorry, 64 goes nicely into 128. So I'm going to go cube root. I'm going to call you 64 times 2, like that. The next ones, I'm going to put these in groups of 3. So I'm going to have the cube root of x cubed x squared. I'm going to have y cubed, and y, like that. I put them in groups of 3 because we have a cube root. Now let's deal with the numbers. If it works nicely, it goes on the outside. If it doesn't, leave it on the inside. So I'm going to go here. The cube root of 64 is 4. That can go on the outside. Cube root of 2 doesn't work out, so I'm going to go cube root 2. You stay right there. Looks like when I cube root these, 1x is going to go on the outside, but 2 are going to be left on the inside. Same thing for the y's, 2 on the outside, so y squared on the outside and y on the inside, like that. And you've got it. Try the next one, a fourth root of 32. Okay, if I look through my fourth roots, I look on my paper. Oh, 16 goes nicely into 32, so I'm going to call this the fourth root. I'm going to just call it, I'm going to start to just put things all together, make it go a little quicker. I'm going to go 16 times 2. Take my ends and put them in groups of 4, so I'm going to go n4, 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 like that. So I chopped up the number and also chopped up the ends as well. Anything that works nicely, the fourth root of 16 is going to be a 2, with the fourth root of 2 not working nicely, so it's going to stay. Looks like all of these go nicely, so we have n power 3 on the outside, and you've got your answer. Last one, we have a cube root of 54. So if I go on my paper, cube root of 54, we have 27. So I'm going to go cube root 27 times 2, and then put these in groups of 3. So I'm going to have p power 3, p power 3, and p. Q9, or would be Q3, Q3, and Q3, like that. Now, to finish, a cube roots nicely, so a 3 on the outside. Cube root over here. Ooh, let me make sure I get that on the screen. The 2 is left on the inside. Here's 1 on the outside, 2 on the outside for p squared with 1 left on the inside. All 3 of these go nicely, so you have q power 3 on the outside. All right, we'll stop right there. You don't need to do the bottom 2, and you can get your homework.